Hi, this is Richard from the DataRobot product team, and this is DataRobot MLOps. MLOps is the way to deploy and manage all your production models for your entire organization. It covers any deployment scenario regardless of where the model was created or how and when it was deployed. It doesn't matter what ML solution, notebook, or languages your data science teams use. MLOps provides a centralized system to manage them all. MLOps is designed from the ground up to provide machine learning specific and production grade monitoring for any production model. You can track model health, drift, and accuracy in real time and understand overall performance and usage. MLOps automatically manages the lifecycle of your models. It alerts you when models are degrading and provides a champion-challenger process that continuously learns and automatically builds alternatives for you, so your models always stay accurate. And MLOps provides centralized governance for all your production machine learning models to manage access and risk and ensure regulatory compliance. In today's demo, we'll walk through a typical day in the life of a financial services company running a center of excellence for delivering ML in production, or as we call it, MLOps. We'll see the types of administrative activities our MLOps engineer George performs, as well as understand how he works with Mary, our lead data scientist. George and Mary rely on each other to effectively build, deploy, and manage models for their company over their full life cycle. And finally, we'll look at how easy it is for Ina, our loan specialist, to use the models that George and Mary deliver. She does this using an automated AI application that Mary built for her. This enables her to approve or deny loans with full confidence and trust in her decisions. So let's get into the demo. George, the MLOps engineer, just opened up his laptop. He sees a notification from DataRobot and clicks on it to investigate. In Slack, he sees a history of automated notifications, triggered by various events like the creation of a new deployment or a service health issue with a production model. This particular notification tells him that Mary, one of his company's lead data scientists, has requested he review the home loan approval model for deployment. George asked Mary to update the importance level in a meeting earlier today. George clicks on View Deployment, which takes him into MLOps, and specifically into the deployment that he needs to review. MLOps provides George's organization with a complete framework to govern all his company's machine learning models. Users are assigned roles to review and approve various events, like creating a deployment or replacing a production model. George quickly checks the governance log. Like all deployments in MLOps, he can review a complete audit trail, showing him every event and who was involved. He verifies Mary upgraded the importance level to high. He can now add a quick comment and approve the change. This changes the overall status to approved, indicating it is now a production deployment. George decides to check in on his other production deployments before logging out. The deployments dashboard provides George with visibility into all his organization's production models, regardless of how they were created and when or where they were deployed. He currently manages 60 active deployments for various business units across his company. He notes that they have served over 1.8 million predictions in the last 7 days. As George scrolls down, he sees that some models are deployed on cloud platforms like GCP and AWS. Others are deployed on DataRobot's prediction servers in his own data center. The dashboard also shows the importance level, so he understands which deployments are mission critical. In George's company, predictive models are written in a variety of languages, including Python, Java, R, and more. Some were created in DataRobot's automated machine learning product. Regardless of how and where they were created or deployed, MLOps enables George to monitor and manage them all from a single pane of glass. Toggling over to the prediction health view, he can see the status of any deployment in terms of service health, data drift, and accuracy. George notices that the lone value predictor model deployed on GCP has a service issue and looks like it hasn't served any predictions for a day or so. He clicks on the model to investigate further. This particular model, written in Java, is running on Google Cloud, the platform of choice for the marketing department. A DataRobot monitoring agent has been instrumented within this environment and is sending metrics back to MLOps, so George is able to monitor it. Clicking on the service health view, George is able to view metrics such as total predictions and requests, response times, and error rates for this remote model. Scrolling down, he can see any metric over time. It definitely looks like the model has stopped serving predictions in the last few days. He clicks on the data error rate panel. It looks like a data issue is causing the problem. To understand root cause, he segments the data by consumer. These are the remote applications requesting predictions from the model. It looks like there's no issue with the West Coast server, but clearly something's going on with the East Coast server. It's probably been sending unexpected data that the model doesn't know how to handle. Now that George has identified the cause of the issue, he can make a call to the DevOps team that manages the East Coast infrastructure to get the issue resolved. Back on the main dashboard, George notices an issue with another deployment. It looks like the lone default prediction model has a data drift issue. Furthermore, accuracy has dropped over 10% since it was trained. This is a model written in Python and was deployed to a DataRobot prediction server. It looks like Mary owns this one. George isn't a data scientist, so needs to get her involved in the troubleshooting process. Mary, our lead data scientist, logs into MLOps to investigate. She was suspecting something was up as she also received a Slack notification from DataRobot earlier today. Looking at her dashboard, Mary sees all the models she owns. This is a subset of the models that George has access to, since she is not an administrator. She drills into the problematic deployment. The first thing she decides to take a look at is data drift. This is usually an early warning sign for accuracy issues down the line. This page shows her how prediction data changes over time from when she originally trained the model. On the left, each dot represents a feature. There are just a few here, but MLOps can track thousands for any model. Feature importance is shown on the x-axis, and data drift severity on the y-axis. It looks like the lone grade feature has drifted significantly. Clicking on it, the chart on the right shows her the range of values for lone grades. The original training data is dark blue and the more recent prediction data is light blue. Mary notices that the model has not seen any E grades recently. Such a large disparity between training and prediction data often cause models to degrade. As Mary moves the time slider backwards, it shows her when the feature started to drift. Looks like it was sometime back in June of this year. This page displays accuracy metrics for the model and compares predictions with actual outcomes. In this case, lone default. Mary starts by analyzing log loss over the full lifetime of the model. It has worsened by almost 22%, which is not good. From the chart, it's pretty clear that accuracy started to degrade in July, about a month after the grade feature started to drift, which makes sense. By clicking on the tiles, Mary can see other accuracy metrics like AUC, KS, and Gini norm. They all tell the same story. Further down the page, she sees the difference between the predictions made and the actual values. Here she sees that the model is fairly consistently over-predicting the actuals. Next, Mary checks the model's humility rules. Humility rules keep the model honest. They provide guardrails so that honorable actions are automatically performed when unusual events occur and the model is not sure of a prediction it makes. Mary previously created a rule that triggers whenever the model generates a prediction that's out of normal bounds. In this case, the rule overrides the prediction to a safe value of 1, meaning the loan will default. Clicking on Summary, Mary can see how many times the rule has been triggered in the past. It looks like it's been triggered quite a few times since accuracy started to degrade. This is good. It's a safety net for Mary. It's like having an automated approval process that works in real time for every single prediction. Mary now decides to add a new rule to handle the decommissioned E-grades she discovered on the data drift page. So now, if the prediction data is not one of these valid values, the prediction will be overwritten to the safe value to deny the loan. She adds and submits the rule to her model. Given the degrading performance of the current model, Mary decides it might be time to switch it out for a more accurate one, and moves to the Challenges page. Challenger models are alternative models that can be tested alongside the current production model or champion using the same prediction data. Mary has 2 Challenger models configured. One was built in DataRobot AutoML, she's using this as a baseline model, and another she built in Python. Looking at performance over all historical prediction data, she can see that both of her challengers would have performed better than the current production model over the period when it degraded. This is true in terms of log loss and other metrics such as AUC and KS. This is good news, but Mary is a perfectionist and wants to see how her very newest model would perform, so she decides to bring in a new challenger. Clicking on Model Registry, Mary can see all of the staged models and model packages she has access to. She could add her model as a new model in the registry, but since she's built other versions in the past, she decides to register this one as a new version of the existing most accurate model. She clicks New Version and enters a description. The next step is to add her code. She could add it from a local source, but MLOps also connects to remote repositories, and Mary likes to use GitHub. She selects the Data Science Script repository in GitHub and is prompted to enter the branch and path to her code. Quickly toggling over to Mary's GitHub account, we can see the code artifacts for her model that she version controls in GitHub. She wrote this code in Python, as we can see by scrolling through the notebook. She now grabs the path to her model and copies it to her clipboard. Back in MLOps, she selects the master branch and pastes in the path to her model artifacts. Once the pull from GitHub is complete, she can view details on everything that was imported into the new 3.1 version of the model. She also gives the version a name. After her model package is added, it's easy to upload it into an environment to prepare it for deployment. In this case, we're using a drop-in environment that DataRobot provides out of the box for Python 3 scikit-learn, but you can just as easily create your own environment. The next step is to test the model on a sample of data to see if it's ready for prime time. She clicks on Test Model and selects a sample dataset that's already in DataRobot's AI catalog. Then starts the test. The test validates that the model is stable and won't run into any errors when making predictions. With a successful test, a new version is recorded here. Mary also has access to a complete test history of all her model versions. She double checks the log from the test she just performed. Everything looks good. Now she can add the model as a package in the model registry, so it can be staged and accessed for deployment. To add this new model as a challenger, Mary navigates back to her problematic deployment and clicks on Challenges. From there, she selects Add Challenger Model and picks the model package for version 3.1 that she just added to the registry. Clicking Add Challenger adds the model alongside the other two challengers and the current champion. Now, all she needs to do is update her new challenger with the historical prediction data to see how it would have performed compared to the others. She clicks refresh a few times so she can watch the new challenger appear on the graph, here in light green. Mary wants to compare her new model with her other challenger to see if it has a little better accuracy. It's pretty close, but toggling to AUC, she can clearly see that this new challenger performs a little better. She's now confident that she can replace the current production model with her new challenger. Mary clicks on Swap Model to perform the replacement. This change will need to be approved by George. Mary elects to have the changes applied as soon as they are approved and selects accuracy as the reason for the change. She then picks Accept and Replace and is notified that the change request is created. Logging back in as George, we see that Mary's change request is pending on his dashboard. He clicks into the model, double checks the audit trail, and then clicks Add Review. He then approves the change request. The old model is replaced and Mary's new version is now deployed into production. There was 0% service interruption during this event. George calls this model hot swapping. Back over with Mary, she logs in again to see the model is live and all lights are green. Good news. She can now create the new application for her business sponsor Ina from Risk Management that she has been asking for. She clicks Create Application and selects the Predictor app. This is a web app that's deployed to a server and will communicate with her model over a REST API. She deploys the new application and then shares it with Ina and sends her a quick message. Ina, the business user who works in risk management, opens her iPad to check out the new app. She's with a client and has a loan she needs to approve right away. Ina uses the app to create a new record for the loan application number 22323. She then fills out the form with details specific to this applicant, such as an interest rate of 5%, a loan grade of C, and that the applicant's annual income is $100,000. She then taps on Get Prediction. The app tells Ina that this applicant is only 8.52% likely to default on the loan and gives her explanations for the prediction. Each explanation is a feature from Mary's model that has influenced this prediction. In this case, the applicant's salary, interest rate, loan term, and purpose, which is to buy a new car, was seen as favorable. This gives Ina the confidence to approve the loan. We hope you enjoyed the demo. To find out more about MLOps, please please visit our website at datarobot.com/platform/MLOps or join the DataRobot community. Thanks for watching.